Let there be gravity. The goal of our lab was to see if objects would become weightless during freefall.
And also to test how fire would work in the exact same scenario.
The nature of gravity was first discovered by Sir Isaac Newton about 300 years ago. Gravity, or the force of gravity, is an attraction between any two objects with a mass. This is most noticeable when one mass is larger than the other, for example, an apple to the Earth. The attraction to the Earth is known as normal gravity, or 1g, which is also equal to 9.8 meters per second squared.
S is a constant. The matter that makes up any object is the same no matter where it is. Weight varies though. Any object weighs more on Earth than it does on the Moon, because the force of gravity is stronger on the Earth than it is on the Moon. It can vary on any different planet. If you drop an apple on Earth, it enters freefall and it accelerates and continues to accelerate due to the force of gravity. If you drop an apple from the space station, the same thing happens. But the reason nothing appears to be happening is because the apple, the astronaut who drops the apple, and the space station are all falling at the same rate due to the acceleration of gravity.
As the fire consumes the oxygen and heats up the air, the hotter air rises, while the cooler and heavier air sinks because it is heavier thanks to gravity.
However, in microgravity, there is no lighter or heavier air. Therefore, the air that is burned just sits around the flame, causing it to burn slower.
The materials we used were pretty basic. We used a wooden box to hold the flame and objects, a scale to test weight, and a phone to record video inside the box. Also, a rope was used to catch the box when it fell. We used a tea candle for our fire and rocks and a 1-pound dumbbell as our weights. Lastly, our setting was the FLB park, so we could use a tower to drop the box from a high place.
We started off with a scale, some rocks, and hand weights. We placed this on the inside of the box, and then we had to attach a cover to the outside of the box so that the contents on the inside would not fall out. We then attached the camera to the outside of the box where the hole was so that we could record everything going on inside the box while being able to control the camera from the outside of the box. We then dropped the box with the contents in it and then viewed the footage after. Once this was done, we repeated the process by taping a candle on the inside of the box. We lit it and did everything the exact same.
One. Okay.
We did it!
In 3, 2, 1.
3, 2, 1.
As you can see, the weight registered on the scale is close to 1 pound before the drop. At the moment the box is dropped and enters a state of free fall, the scale drops to around 0 because the box, the scale, and the weight inside all begin to fall at the same acceleration, making it to appear as if the weight on the scale becomes weightless, until of course the box catches the string and gravity pulls the weight down on the scale, registering a weight again.
Next, we decided to see if the same concept would be applicable to something with a greater mass. So we tested it with 3 pounds and the same thing occurred.
As you can see, the flame burns slower in all directions equally, forming a globe-like shape. This occurs because gravity cannot pull the heavier, oxygenated air down to the base of the flame to replenish the fire.
From our observations, we were able to tell that objects in free fall do become to seem weightless when they are fallen, regardless of their mass.
We were also able to tell that when a flame is entering freefall, it gets away from its traditional form of a teardrop and enters the form of a sphere.
This just goes to show us how important gravity is to us and how it really affects how we perceive the world, because as we proved in a free fall, there's a lack there of gravity for a split second, and that can really change things with the weight and the shape of things. So gravity really does have a big impact on how we see the world, and we can use this information to really change the way we think of stuff in the world and view how we don't just have to be in space to see the lack of gravity and how that can have an effect on objects.
So some sources of error of our lab would be that when we dropped it with the fire on the inside, there was a gap in the box, so near the end of the free fall, a bunch of air rushed in and put out the fire. We also could have dropped it off a higher tower so that we would have longer footage to observe.
Also, when we dropped the box, we weren't consistent about how we dropped it. For example, it would tilt, which could change the scale. Also, on the inside of the box, the scale isn't taped down, so it must have been moving, which would have changed things too.
And the scale itself had a little like bar thing where a bowl sat on top, which to hold the contents, but they weren't actually attached. So in the state of free fall, when everything's accelerating at the same rate, the bowl could come off the scale a little bit, and so it wouldn't be pressing on the scale, which the scale was set to 0 with the bowl on it, so it accounted for that weight. So if that weight came off, that's why you could have seen the thing go a little past 0 on one of the revert runs.
How's it going up there? What are your thoughts on this physics project compared to your last one?
Well, we really took the criticism compared last time about practicality, because honestly, building a generator was great, cool, fun, but then how wordy we made it, except, you know, it was just kind of thrown out after a little while and forgotten about, whereas, like, your knowledge on a certain thing such as gravity will always stick with you no matter what, and also the ability to practice something that you'll actually use, like a formal lab, will really benefit us. So the more practice, the merrier, and it's something we can always keep with us, so it's more practical and it's more beneficial in the end.
What did you like about this lab?
I really like the real life application to it. In the next few years, we're going to be doing a lot of labs in the university, and this kind of reminded me of what that's going to be like. It was more so, we have a question, and we're going to go answer it, and kind of developing a process that's going to let us do that was the most fun part.
What have you learned from this wonderful physics project?
The biggest thing would be really what the force of gravity really is. Before this lab, I thought the force of gravity was just everything being pulled to the center of the Earth. But now I really do understand that there's a force of gravity between every object. You can't really tell between two apples per se, but when the size difference is really substantial, like the Earth and a person, or the Moon and a person, that's when you can tell that there's a force of gravity. I also reiterated kind of my knowledge about weight and mass. I didn't really understand it completely before, but now I understand that weight is a force that is affected by the amount of force of gravity on a certain planet, and that mass is always constant, and it's the amount of matter that makes up an object, so that never changes.
In conclusion, the two things to take away from this are that objects in freefall are weightless.
And also that the lack of gravity can change the shape of an object, such as a flame.
Okay. No more gravity for you.